So in this video, we're going to be looking at finding the equation of the tangent line, or the line that's tangent to a particular curve. So just to kind of give you an idea of what we're talking about here, let's say that we had some function. It doesn't really matter what the function is. I'm going to draw in, sketch in some kind of function here. Let's say that we had maybe a function that looked like this. And we were interested in, say, at this point, maybe 3. Okay, so when I'm evaluating this thing, I want the equation of the line that's tangent to the curve at this point right here. So what I'm looking for is the equation of that line. Now, the thing that you need to notice about this is that, first of all, this point of tangency belongs to both the point, or excuse me, to both the curve, the function itself, and it belongs to the tangent line. So if I can find out what that ordered pair is right there, I know that I have a point to work with for my point slope formula for the equation of the line. The other thing that I would need is the slope of this tangent line. Remember that the slope of the tangent line is the value of the derivative at this point x equals 3. So there's two things that I have to find here. The first thing that I have to find is I have to find the ordered pair. That's the point of tangency. And the other thing that I have to find is the value of the derivative, which tells me the slope of the tangent line at the point of tangency. Okay, so let's see if we can put this into practice a little bit with a couple of functions that we have. The first one that I want to look at is, let's say that we have the function f of x equals x squared plus 5 divided by x cubed minus 2. And I'm going to see if I can find the equation of the tangent line at the point x equals 2. So the first thing that I need is I need to know what the y-coordinate is for that point of tangency. To find that, remember that the point of tangency belongs to both the curve and to the tangent line. And so the easiest way to find the point of tangency is just to plug 2 into the original equation here. So if I do that, I'm going to get f of 2 equals 2 squared plus 5 over 2 cubed minus 2, which is going to give me 4 plus 5, which is 9, over 8 minus 2, which is 6. And so my y-coordinate for my point of tangency is 3/2. So the point that I'm working with is the ordered pair 2, 3/2. Now remember, we need the equation of a tangent line. To find the equation of a tangent line, I need two things. I need a point and a slope. Now I have my point. The other thing that I have to find is the slope of the tangent line at x equals 2. Slope of the tangent line is found by taking the derivative. So I'm going to take f prime of x, and I'm going to have to differentiate this using the quotient rule. When I use the quotient rule here, the derivative of the numerator is going to be 2x times the denominator, which is x cubed minus 2, minus the numerator, which is x squared plus 5, times the derivative of the denominator, which is 3x. And then all of that is divided by the denominator squared. Okay. Now, there's a lot of algebra that we can do to simplify this thing, but I think it's really unnecessary because I really don't care what the actual function is for the derivative. All I really care about is what the value of the derivative is when x equals 2. So rather than trying to go through and simplify this thing algebraically, I'm going to actually go ahead and say, okay, what's the value of that derivative when x equals 2? To find that, all I got to do is plug 2 in for all of the x's here. There's going to be a lot of 2's involved. That's going to give me 2 times 2 times 2 cubed minus 2 minus 2 squared plus 5 times 3 times 2, all divided by 2 cubed minus 2 squared. Now this is just an arithmetic problem to solve. I just have to go through and find this thing arithmetically. And so I'm going to go through and say, I'm going to do this as quickly as I can here. That's going to be 2 times 2 is 4, 8 minus 2 is 6, minus 2 squared plus 5 is 9, 3 times 2 is 6, all over 2 cubed minus 2, that's 6 squared is 36. This is going to be 24 minus 54, which is negative 30, over 36, which reduces to negative 5/6. So arithmetically, this is relatively simple to solve. Remember, I didn't really have to go through and simplify the derivative function at all. I didn't care particularly what the derivative function was. Only needed to know what f prime of 2 was, and that's going to be negative 5/6. So here is my slope of the tangent line, my m value. Here's the point that I'm working with. I have a point, I have a slope, so I can write the point-slope formula for the equation of the line. That's going to be y minus the y-coordinate, which is 3/2, equals the slope, which was negative 5/6, times x minus the x-coordinate, which is 2. And there's my equation for the tangent line. Now, you may want to go through and solve this for y, put this in slope-intercept form. A lot of students will do that. It's really not necessary. This is a perfectly legitimate equation for a line. I wouldn't touch it. I would leave it just the way this is. The only thing that can happen when you try and simplify this and put it in point-slope form is that you might make some kind of simple algebraic error and end up with a different equation for a different line. So I would leave it just like this. So that's the first one we're going to look at. We found the equation of the tangent line at x equals 2 for this function here. Let's try another one here. This one's going to be a little bit more complicated. Let's go through and say that we had the function xy squared plus 3x equals 2y plus 10. And we want to find what the equation of the line is, what the equation of the tangent line is at the ordered pair 3, 1. Now, I believe if you go through and you plug 3, 1 into here, you'll get a statement that's true. So this point is on this line. So we've already been given the point that we need to work with. We just need the slope of the tangent line, but this is going to have to be done implicitly. So let's go through and differentiate this problem implicitly. I'm going to use the notation y prime as I go through this. First one here is going to require the product rule. The derivative of the first function is 1 times the derivative of, times y squared plus the first function, which is x, times the derivative of y squared, which is going to be 2y, y prime, plus the derivative of 3x, which is 3, equals the derivative of 2y is 2y prime, and of course the derivative of 10 is 0. Now, we can go through and solve this for y prime like what we were doing in previous lessons when we were just working with implicit differentiation. But again, I don't really care what the derivative function is. It really doesn't matter to me. And so what I'm going to do, I know the ordered pair that I'm interested in, so I'm going to plug in 3 for x and 1 for y. That's going to get rid of all of the x's and y's here and just leave me with y prime. And then I'm going to solve for y prime that way. When I do that, I'm going to get 1 times 1 squared plus x was 3, y was 2, y prime, plus 3 equals 2, y prime. And I go through here and I go, okay, that's 1 times 1 squared is 1, plus 6y prime, plus 3 equals 2 y prime. I'm going to collect my terms that have a y prime, so I'm going to subtract 6y prime from both sides. I'm going to combine the 1 plus 3 is 4. 2y prime minus 6y prime is negative 4y prime. And I find that y prime is equal to negative 1. It was a lot easier than going through and trying to solve that for y prime and then plug in the x and y values. So now I have the point that I'm working with. I have the slope of the line that I'm working with. So now I'm ready to write the equation of the tangent line in point-slope form. The equation of the tangent line is going to be y minus y1, which is 1, equals the slope, which was negative 1, times x minus 3. There's my equation for the tangent line. And again, I wouldn't go through, this one's a little easier to do, solving this and putting this in slope-intercept form. I still wouldn't do it. This is a perfectly good equation for a line, and so there's no point in messing with it at all. This is one of the key things that we do with derivatives. We find equations for tangent lines. This is the process that we use for that. Again, the most important thing in this whole process is being able to do the differentiation, recognizing your shortcut rules so that you can find the slope of the tangent line correctly. That wraps up this, this material on just basic differentiation techniques. We're going to start looking in our next videos and forward. We're going to start talking about actually applying the derivatives and seeing what these things actually do. There's a lot of powerful stuff that we're going to be looking at in the next few videos.